Hello, my name is Alex Nielsen, and I'll be presenting lab number 5, electric motor for Physics 205. So as you can see here, I've constructed a simple electric motor using the lab home kit and some home materials. Now the idea of an electric motor is that it converts electric energy into mechanical energy. So what we have here are two 1.5 volt batteries, which are connected in a circuit which has two metal posts and a copper coil in the middle, and above a permanent bar magnet. Now, how the motor actually works is that once the current starts flowing, the magnetic field of the bar magnet creates a torque on the loop, causing it to spin. Now, torque, the formula for that is the number of turns in the loop, which in this case is 5, times the current, I, which I measured at 0.12 amps, times the area, in this case 2.51 millimeters squared, and the sine of theta. So in this case, theta is a very important parameter because that's actually the angle between the radius of the loop and the point of application of the force and the force vector. So as I mentioned, the force vector is created when current is flowing, created by the magnetic field. And using the right-hand rule, you determine the direction of the force. Now, in this orientation, you have on this edge of the loop, you have a force vector going up, and on the bottom, you have a force vector going down. So there is actually no torque because the theta in this case is 0 degrees, and sine of theta is 0. However, in this orientation, theta is actually going to be 90 degrees because, again, that's the angle between the radius r and force vector. So on one side, the force vector will be pointing up, the other side will be pointing down. And at that point, you have maximum torque. And again, the sine of 90 degrees is 1. So that gives you your maximum torque. Now, what will happen is the coil won't want to spin, but once it reaches this point, it'll just want to oscillate back and forth in its equilibrium point because, again, in this orientation, theta is 0, there is no torque. So to get around that, what I've actually done is first strip the coating on the coil and covered one side with a black Sharpie. So what will happen is, once you give the coil a little push, it'll go through its point of max torque. And then at this point, instead of just oscillating back and forth, when the coated sides touch, the current will stop flowing. The momentum will allow the coil to just keep going forward to this orientation, causing torque to be applied, and it'll spin back, and then the cycle will repeat itself. So that's how you get around that issue and cause the motor to keep spinning. So with that being said, let's give it a shot.